Okay, we are going to do the YTSS Combined Physics 201 for Prelim paper. So this paper is pretty easy for paper 1 and paper 2 you may face some issue, but on average you should be getting at least a high B or low A. So let's begin. Okay, question one is on measuration. So if you have something that is more than say 10 cm, you cannot use vernier caliper, or anything more than 15 cm you cannot use vernier caliper, so you have to use meter rule. And anything that is less than 1 mm, basically vernier caliper will be too big, so you have to use micrometer, so therefore the answer is A. Okay, then for question 2, you need to know that the period of the pendulum depends on the length of the string and the gravity, and it is independent of the mass. So the mass is basically a distractor, and since we are doing it on Earth, the gravity will be the same for P and Q. So the only factor that's affecting the period will be the length of the string. Now you may ask me, why am I looking at the period when the options are regarding swinging faster or slower? Okay, well, if you swing fast, it basically means that your period has to be small. Okay, because the period is defined as the time taken to complete one oscillation. So therefore, the faster you swing, the faster you complete one oscillation, and therefore the lower the period. So basically the relationship is that when the string is short, then the period will be low. So therefore the option is D. Okay, then for question 3, basically you need to know that the net force is equals to m times A. So using this Newton's second law, on the right hand side you are given the mass already. Okay, you need to take note that the net force is not a singular force but a summation of these three forces. So these three forces are vector, so if we take the right hand side to be positive, 7 and the 3 Newton will be positive, and the 12 Newton will be having a negative signage, okay, because it's going to the left. So F net is defined as the summation of forces. Okay, so you sum this up, you get some number, and then you just divide by 1, you get -2 meter per second square. So the acceleration is going to the left. Okay, question 4, basically you need to know this formula. The weight is equals to mass times gravity, and the gravity in this case can be understood as the gravitational acceleration. So this acceleration due to gravity refers to this g. So you need to take note that the unit g actually has two forms. Well, you can say forms. One is meter per second square, one is Newton per kg. Okay, both are g's unit. So when you refer to g as gravitational acceleration, it will take on this unit. If you refer g to gravitational field strength, then you can use this unit. Okay, so basically to find out which planet has the greatest acceleration due to gravity, you make g the subject, and then you substitute this pair of value into the equation. You will realize that option C will have the greatest gravitational acceleration. Okay, for question 5 is a bit complicated. There are two approaches. Okay, number 1 is that you need to know what is power. So power is defined as the rate of energy change per unit time. So if you look at the rate of energy change from the bottom of the stair to the top of the stair, you can take it as, because at the beginning, at the bottom of the stair, the student is not moving. It started off as stationary. So therefore you can use this position as an inertial position, and in this case okay, let's draw it again. So I have this stair. Okay, this is my initial position and this is my final position, right? And at both positions the students will remain stationary. He just climbed the stair and then he just stand there. So meaning that if I look at the total energy at inertial position, I will have PE, KE, and KE will be equals to 0 because I'm not moving. And P is 0 because I will define the bottom of the stair as 0. So therefore the top of my stair will be H. So the final energy that I'm looking at will be KE equals to 0 again because I'm not moving. And then PE will be basically equals to mg times H. So if you substitute the correct values into the mgh, you got 2250. And the energy change between final to initial is just 2250 minus 0. And therefore, down here you can simply put 2250 divided by the time taken for this change to occur. So you get 225 watt, and you will get the answer, option C. Okay, so now there's another approach. The other approach is to look at this energy in terms of work done. So if you look at work done, at the bottom of the stair, the only forces that is acting on the student is the force by the earth, which is the gravitational pull on the student. So the gravitational pull on the student is basically your W equals to M times G. So then you will get 450. Okay, you would now know that, okay, the student is under a force 450 Newton. And so once you have the force, you can then calculate the work done. Now the formula for work done is a little bit tricky. It's equals to F times D, but this D, right, has to be in the it has to be along the direction of the force, So since the weight is a vertical force, I can only take the vertical distance. Okay, so the 7 meter here is basically a distractor. Okay, it has no purpose in any of the calculation. Okay, I repeat, the force here on the student, because we are interested into finding the work done of the student, so I have to find the forces acting on the student. So in this case, the only force that is acting on the student is the gravitational force on the student, which is 450. Now the gravitational force is acting in a vertical direction. So therefore, my distance here, I have to consider the vertical direction as well, vertical distance. So therefore, I have to choose the word 5, and you see that you get 2250. So since now you have the work done, and you can substitute into this E as well. Okay, so this E can take on to 2250, which is the rate of work done, and it will be over the time taken for this work done to complete. So again, you get 225W. Now some of you may be asking me, then teacher, how come initial and final position here you didn't add the work done? Okay, the reason why is that at this initial position, when we talk about initial position, we are talking about a fixed time frame, the initial time frame. So if we are talking about the initial time frame, and if you look at it, yes, there will be still a gravitational force pulling it down. But at this instant, the initial time frame, is the student moving? That means when you look at the initial position, you imagine that you pause time. If you pause time, it means that the student will not have moved any distance. Am I right? It doesn't move any distance. So distance is 0, and therefore down here you won't have the work done. Okay? Again, same thing happens here. If you look at the final time frame and you pause the time, the student does not cover any distance. So therefore, F times 0. Therefore, you do not need to consider work done when I'm comparing the initial and the final and total energy. Okay, so therefore you will still get 2250 using either approach.